Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome to the post contest analysis of Byvisit School Coding Tournament, and this is the 15th coding tournament that we had in this Byvisit session. So, before we begin, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? All right, so it seems like everything is fine from my end. So, okay, we are going to start our session. And sorry for the delay. Actually, it's raining quite heavily here, so I had a network issue. So that's why I was not able to start the session at 7:30. But no worries, we are going to start now, and I'll be taking up all the questions that was there in today's contest, and we will be solving them one by one. So to start with, first of all, we will be solving the quiz problems, and then we will move to the coding solutions. All right, let's start with the quiz problem. So what does the first problem says? All right. So it says that in an IPv4 addressing system, what is the maximum number of unique IP addresses? So for that, we have a direct formula. We have 2 raised to the power 32 minus 2 number of unique IP addresses. All right. So that is the correct answer to this question. Now, the next question says, how many distinct binary search trees can be created with 4 distinct keys? All right, so to find this, we have a formula that is 2n divided by n plus 1. So let me write down the formula. All right, so this is the formula that we have, that is 2n Cn raised to the power n plus 1. Okay, and in this case, we have n as 4. So if you will write it as 8c4 divided by 5, it will give you an answer of 40. All right, so that is our correct answer to the question. Now let us move to the next question. So 14 is the answer to this question. Now the next question says, which one of the following is true for a variable declared with let in JavaScript? So the correct answer to this question is that it cannot be redeclared within its code. All right. So like if you are declaring a variable with the keyword let, you must keep this in mind that you can't redeclare it. All right. That is, now next is, we have, which of the following machine learning algorithms is based on the principle of ensemble learning? So out of all these things, the correct option is random forest. It is based on the principle of ensemble learning. All right. Then we have the SHA-256 algorithm used in Bitcoin blockchain is a type of what? Okay. So this is basically, we have the correct answer to this question is Okay, so this is we have question number 5. It is a hash function. Okay, the SHA-256 algorithm, it is basically a hash function that is used in the Bitcoin blockchain. All right. Next we have question number 6. That is, what is the time complexity of inserting at the beginning in dynamic arrays? So by dynamic arrays we mean vector, right? So what is the time complexity if we are inserting inside a vector? So that is basically a linear time complexity. Okay, because if you are inserting it inside a vector, then you will need to shift all the elements towards its right. All right, so you will need to do a linear traversal of all the elements. That's why its time complexity is big O of n. Okay, next question, in computer graphics, what does the abbreviation GPU? So it is basically a graphical processing unit. Okay, that is the full form of GPU. All right, let us now move to our next question. Which of the following algorithms is not a path-finding algorithm? So the correct answer to it is Kruskal's. It is not a path-finding algorithm. What it is used for? It is basically used for if we want to find out the minimum weight, right? Like a Prim's and Kruskal's algorithm are used for the same thing. That is the minimum spanning tree. Whenever we used to find, okay. So for that we use this algorithm. All right, Kruskal's. I mean, for finding the minimum spanning tree, we use Kruskal's algorithm. Thus, it is not a path finding algorithm. All right. Next, we have, which CSS property is used to change the left and right margins of an element. So, if you want to change the margins, so basically you will have to use the margin command. All right, that is there, that we can use. Next, we have, in the context of AI, what does the term neural network refer to? So, what is neural network? As you know, they are basically trying to connect towards the neurons that we have in our bodies, in our brains, basically. So, the correct answer to this question is human brain, a computational model which is inspired by human brain. Okay. Next, we have, given a Turing machine M, the problem of determining whether M halts on all input is okay. So, if we want to determine this, then basically it is undecidable. We can't decide it not on the basis of the information that is provided. All right. So, that is undecidable factor for us. Now, the next question. Given an unsorted array of n elements, which of the following algorithms will take the kth smallest element in linear time? So if we want to have a linear time for this, then we'll have to use the quick select algorithm. Okay, so that is the answer, because none of all the three sorting methods that is given, that is heap sort, quick sort, merge sort, they are going to take a time of n log n, but in quick select we can perform it in a linear time complexity. So that's the correct answer. Okay, next we have, in graph theory, the seven bridges of Königsberg is a historically notable problem. What fundamental concept does this problem lead to? So, this is a very famous concept. So, this is basically used for the concept of Eulerian paths and circuits. All right. So, that is the answer to this question. Next, we have, how many spanning trees does a complete graph with n vertices have? So, there is a direct formula for it, and the correct answer to this question is n raised to the power n minus 2. All right. Next, we have, in a public key cryptography system, what is the primary function of the private key? So, why do we use private keys? So, it is basically used to decrypt the messages. All right, to encrypt the messages, we use the public key, and to decrypt them, we use the private key, which is with the sender and the receiver only. All right. Next, we have, in computer graphics, what does the term rasterization refer to? So, what is rasterization? It is basically if you convert it from vector graphics to raster graphics, that is known as rasterization. All right. Next, we have, in computer science, endianness refers to what? All right. So it basically refers to the order in which bytes are stored in the memory. Okay, it's the meaning of this word. Next, we have what is a list comprehension? So it is a simple way of creating a list using a single line of code. All right. Just the basic definitions that we have, not any calculation. Now, what is the primary difference between a compiler and an interpreter? So I expect it's a very common question that all of you might be knowing already. So what does a compiler does is it basically translates the entire program before executing it, while an interpreter translates one statement at a time during the execution. All right. So compiler works before the execution and interpreter works during the execution. All right. So option A is the correct answer. Next, we have, which of the following languages is not a Turing complete? So Python, Java, C++, all three of them are a Turing complete language, but HTML is not. So that is the correct answer to this question. All right. So I hope all of you are clear with this quiz part. If there is any confusion, please drop it down in the chat section so that we can discuss it. Or else we will be starting with the coding problems that we have. All right. So there doesn't seem to be. Hi, Usha. I hope everything was clear to you as well. Okay. Now let us move to the coding problems. So now let us solve this question first. That is buy two items. Okay. The question says that let me just reduce the font size. All right. So what does the question statement says here is that Geek visits Geeky Land and goes to Geek store. There are n items for sale. Geek will only buy two items such that the sum of price of both the items are greater than or equal to A and less than or equal to B. Alright, so we are given a vector containing the price of each item and the values of A and B. We need to return the total number of possible pairs Geek has an option to buy. Formally, we need to find the number of pairs such that the sum of two numbers is greater than or is equal to A and less than or is equal to B. So let us try to understand it with the help of an example. Like what we have here is, yeah. So in the example we have here A4, B7 and price is 512. So A that is given to us is 4, B is given to us and the price array that is given to us that is 512. So now what are the possible options that we have so that it satisfies the condition? That is we have 5 plus 1, it will give us 6. 5 plus 2, it will gives us 7. Now 6 lies in the range from 4 to 7, right? Close bracket because 4 7 both included, and 7 also lies in the range 4 to 7. Okay, so these are the two possible pairs that we can make. So the correct answer to this question is 2. Okay, now let us look at how we can solve this question. So basically what we are trying to do here is we are trying to find out two elements whose sum is greater than is equal to A and less than is equal to B. Okay, so first of all, how we can get the intuition to solve this question? So as it is clear to us, we are trying to find the sum that lies in a given range, right? So let us say rather than the brute force for this question will be brute force approach. Simply we can run a for loop twice. Okay, we can use a for loop. We can run it twice. It will have a time complexity of big O of n square, and for each of the elements we can find out, right? Like let us say 1 2 3 4 is there, then you can find out for one that for with how many elements you can pair one, then you can find with how many elements you can pair two, and so on, right? So that is a brute force approach. But as you see that here the sum are required in a certain range, right? That is A to B. So let us say if we will sort the array, so after sorting it will be become easier for us to find the sum, right? Because let us say we have sorted our array and let us say in this range the sums are lying in the given range that is given to us, that is a to b. So which means that we don't need to perform any operation after this point, right? Because you already know that after this point the sum will be exceeding the value of a, right? So we don't need to perform any operations after this point. So our task will get easier. So that's why first step that we are going to do is that is sorting, because sorting will make our task easier. Now after sorting, what we need to do is we will be using here an inbuilt function that is lower bound. Now, what does lower bound will do? It will basically see. Let me just help you with an example. Let us say the elements that is given to us is, let us say the value of n is 7, a is 2, b is 5. Okay. Now, the elements that we have with us is 1, 7, 2, 1, 3, or let us say 4 or 5. Okay. So, let us say these are some of the elements that we have. Now, what we need to do is, first step, as a first step, what we are doing is we are sorting the array, right? So, let me write the sort command. And then after sorting, our array will be 1, 1, 2, 3, 4, 5, 7. Okay. 1, 2, 3, 4, 5. Yeah. So, this is the elements that we are getting after sorting. Let me do the indexing as well. So, what are the ranges that we have? A is given as 2, B is given as 5. We need to find elements that are lying in this range only, alright? We need to find pair of elements whose sum is lying in this range. Okay. Now, what we will be doing is, first of all, we will be, see, let us say if what we do, if we find the element that lies here, right? Let us say we are searching for one, okay? Now, one can be paired with 2. Yes, it can one be paired with 3? Yes, it can. One can be paired with 4 as well. One can be paired with, no, it can't be paired with 5. Okay. So we can pair one with these three elements, right? With 2, 3, and 4. Correct. This one can be paired with these three elements. Now, if it would have been this one, then the pairs that we can make is 1 plus 1. And then we can have 1 plus 2 again, then 1 plus 3, then 1 plus 4. Okay, so here we are getting 3 pairs, here we are getting 4 pairs. Now, if let us say we are pairing 2, so we can pair 2 with 3. Alright, so here we are getting 1 pair. Now there are no more, so total we are getting 8 pairs. Okay, there are no any more pairs that we can make here, okay, which will lie in that given range. So total number of pairs that we are getting is 8. So if you will carefully look, what we are basically trying to do is, for every element, all right, the value of b was 5 here, right? So for every element we are finding that what is the, first of all you need to subtract it. Okay, like let us say we have created a variable L, and let us say its value is going to be a minus price of I. Okay, so L will contain the value 1, and R is going to contain the value of b minus price of I. That means it will contain the value of 4. Why we are subtracting it? Because basically as if you are searching for 1, it means that 1 is already present inside the sum, right? So if 1 is already present, then we just need to do the searching for the remaining sum that we need, which is basically L and R. Okay, so we are basically doing a search for this range. Okay, now what we are going to do is we will search for the lower bound of R plus 1 actually. Okay, now why R plus 1, that I'll explain later. So first of all, we will be searching for a lower bound of R. Now why we are searching for it? Because let us say in this case lower bound of R is going to be R plus 1. It is going to be this point. Lower bound gives the first element that is greater than or equal to the given element. Okay, it will give me this point, right? Now from this point to this point, from I plus 1, if I will subtract all the elements, I'm getting 4, right? So it will give me the count of total number of pairs that I can make. Okay, so that is the method that we are going to use here. Let us say after sorting, if our array is going to be 1, 1, 2, 3, what was it? 1, 1, 2, 3, 4, 5, 7. So now let me do the indexing. 0, 1, 2, 3, 4, 5, 6. Okay. Okay. So now for I is equal to 0. Okay. What we can do is the value of L is going to be 1, and the value of r is going to be 4. So r plus 1 give us 5. Now what will be the lower bound of 5? That will be the index 5. Okay. So 5 minus I plus 1, that is 1, which will give me 4. And what will be the lower bound for L? That is 1 only. Alright, 1 minus I plus 1, that is again 1. So it will give me 0. So the value that I'm getting from here is 4 minus 0, that is 4. Alright, so which is perfectly correct, which means that this one can be paired with these 4 elements. Let us now move to the next iteration. Let us say value of I would have been 1. So in this case, the value of L would have been 1, and value of R is again 4. Same thing, right? And R plus 1 will give me 5. So now if I will do the subtraction process, so what I'll be getting is, I'll be getting 3 as the lower bound, and then again the subtraction will be from 0 only, so the answer will be 3. So in this way we can continue to run our loop, and we can keep on updating a variable answer with all the answers, okay, with the addition of all the answers, right? So it will contain all the answers. So what we are doing is, like, you just need to keep a track of all the elements that lies in a given range. You need to find the lower bound, you need to find the upper, sorry, you need to find the lower bound of L and R, and then you need to subtract them, okay? So it will give you the count of elements that lies in that range. All right, so that is going to work for us. Now let me show you the code. So this is the code for this question. What we are going to do is, we just need to sort the array, and then after taking out the value of L and R, you just need to find out the number of elements that lies in that given range. Okay, so that is the solution to this question. Let us now move to the next question. It says that Geek is giving by visit contest. After the contest gets over, he absolves the question for better practice. Geek needs your help with one of the questions he came across. Given an integer array of size n and an integer m, find the difference between the maximum and minimum sum of n minus m elements from the array. Okay, so we need to find out the difference. Now, how can we do that? Difference of what? We need to find out the difference of maximum and minimum sum of n minus m elements, okay? And n and m are given to us, all right? So if you will see in the example, we have 5 elements, 1 2 3 4 5, right? Output is 4. Why? Because here n is 5, that is the size of the array, and the value of m that is given to us is 1. Okay, so now n minus m is what? That is going to be equal to 4, correct? So maximum, what will be the maximum sum of 4 elements that we can have? So we will take out the maximum 4 elements, like the elements having the highest values, right? And then we will take out the elements having the lowest values. Okay, so that is going to be the answer to the question. So as it might have been clear while I was explaining it, only what are we trying to do here is, we first need to find out n minus n. Once we have that, we need to find out the sum of max 4 elements. Sorry, let us say this is k. We need to find out the sum of max k elements, and then we need to find out the value of minimum k elements. Okay. All right. So now tell me how we can get maximum k elements, or how we can get the minimum k elements. Simply if we sort the array, because after sorting the array, what will happen? Minimum elements will be here, maximum elements will be here. So we can simply pick up top k elements from the starting, k elements from the end to get the sum, and then we can simply subtract them. All right. So now let me show you the code to make it more clear. Has just we need to sort the array, and then we need to take out the sum of the first k elements, and we need to take out the sum of the last k elements. Okay, that is going to be the answer to this question. Alright, so as you can see in the code itself, we have here sorted our array. After the sorting, we have initialized the sum with maxi and mini value as 0 and the k as n minus m. Now what we are doing is we are running a loop till k, and then we are adding maximum as the sum of the last k elements and the minimum as the sum of the initial k elements. Okay, and then at the end we are returning maximum minus minimum. So that is the required way of solving this problem. Time complexity will be big O of n because there is a single loop only. So now let us move to the next question. It says geeks and the colorful candies. So Geek loves participating in coding contests and solving challenging problems. Today he encountered a problem that involves his two favorite things, candies and colors. There is a row of n candies arranged from left to right, numbered from 1 to n. For each I is equal to 1 to n, the color of the ith candy is color of I. Alright, where color of I is an integer. So, like for every candy, the color is represented as an integer. Now, what we need to do is we need to find the maximum possible number of distinct colors he can obtain by choosing a consecutive group of k candies. Okay, like let us say if it is given to you like 1 2 1 2 3 3 1. So if it is 1 2 1 2 3 3 1. If it is given to us like this, and we need to find out k consecutive, let us say the value of k is 3. It's 3. Let me confirm. Yeah. So we need to find out the maximum number of distinct candies that we can get by selecting three consecutive candies. So if we select candies in this range, so we are getting distinct values. One is 1, other is 2, and other is 3, right? So these are the three distinct values that we are getting for selecting three consecutive candies. So this is what we need inside our answer. Okay. So let us see how we can solve this question. Okay. So basically, as here we are using things like distinct, count. Okay, so we must have built this intuition that we are going to use hash map here. Now, what we will be doing in hash map is, first of all, inside our hash map, we will be storing count of all the elements. Okay. After that, it is 1 2 1 2 3 3 1. Okay. Then, what we will do is, let us say if we are starting our iteration from this point. Okay, now from this point what is happening with us is we will keep a track of whether this element, just a second. Yeah, so inside our map what we will be doing is we will be updating the count of this new element. Okay, inside our map we will be updating the count of this. Let us say we are at and okay, we are running our loop. You must keep in mind we need only k consecutive candies, right? So first of all what we will do is, first of all we will maintain a hash map, and there we will store the value of first k element. So let us say 1 is having a count of 1, 2 is having a count of 1. Okay, and again it is 1, so 1 is having a count of 2. All right, so now what we are doing is first iteration is done till k points. Now we will be starting our iteration from the kth point, that is here 2. Okay, 0 1 2 3 4 5 6. Now what we will do is we will update the count of this element inside our hash map. So now the count of 2 will become 2, right? And we will decrement the count of this element. Okay, that is I minus k, because we need only k consecutive. So if we are considering this element, then we need to delete this element. So we will delete the count of this element. So now the count of 1 will be only 1. Now as we can see in this range 2 1 2, we have two present as two present twice and one is present once, right? So that is the correct count that we are having. And then inside our answer we will be storing the updating it with the current answer and the size of the map, and we will be comparing the maximum of them. So currently the size of the map that we have is with 2. Okay, now let us say we have moved to the next part wherein we are here. Okay, so we had count of 1 as 1, count of 2 as 2. Now if we are here, we will update the count of 3 as 1 and we'll decrement the count of 2, so it is now 1. So now we have the size of map as 3, which is currently maximum. Let us say now we move to this loop. So now we will update the count of 3 as 2 and we will decrement the count of 1, so it will be 0. So now we have map size as 2, and as it is not maximum, so the size will be 3 only. Okay, next we have, let us say we move to this loop. So we'll delete the count of 2, so it becomes 0, and we will update the count of 1, so it becomes 1, right? Now again the size is 2, that is we have only 1 and 3, so the answer will not be updated. So the final answer that we are getting here is 3 only. All right, so in this way we are going to solve this question. What we need to do is firstly solve the loop from 0 to k. After that, start the loop from k to n. Okay, and the steps that we need to do is at mp at I do plus plus, mp at I minus k, we will do a minus minus. Okay, and if after doing the minus, if it is becoming 0, then we will erase that element. Why we are erasing it? Because if element count has become 0, it means that the element does not exist in the given range. All right, so now we will be comparing our answer with the map dot size every time. All right, we will be storing the maximum of it, and then at the end we will return it. Okay, so now let me show you the code for this question. So as you can see in the code, we have used a map here. So first of all, we have updated the count of color, the integers value of color inside our map till kth index, and then we are running our loop from kth index to nth index. And what we are doing, for every new value we are updating the count of map, for every deleted value we are decrementing the count, and if the count has become 0, then we are simply erasing that value from our map, and then at the end we are comparing their sizes. Okay, so in this way we are going to solve this question. It is a linear time taking solution. All right, and an extra space has been used, so the space complexity will be big of n. So that was all about the by visit coding tournament. I hope all of you had a great experience while solving these tournament questions. Make sure you also solve the questions, and if you were able to solve them, then look for the different approaches. If I have used some another approach, maybe you had used some another approach, right? So you can just go through the session and you can look for the different ways of solving the question. If you have any doubts, you can post it in the Discord channel. Mentors are there to help you out. Keep solving the question, and don't forget to register yourself for the upcoming by visit school coding tournament 16.0, right? And also before the starting of any by visit tournament, there is a preparatory lessons that are given on the YouTube, so make sure that you are accessing them as well. All right, so that was all about the today's post analysis session. Thanks everyone for attending it. Wish you good luck with the results. Bye everyone.